Hello folks, welcome back. Till now, we have seen that ECG records electrical activity, not heart contraction. But what exactly is this electrical activity? To understand ST segment, T wave changes, or MI patterns later, we must first understand what happens inside a single ventricular cell. This is called ventricular action potential. Every ventricular muscle cell has an electrical charge across its membrane. Suppose this is a ventricular muscle cell. The ventricular muscle cell is negatively charged inside compared to the outside of the cell, and this is at rest. This phase is also called as a polarized state, and when this ventricular cell gets activated, this results in a series of electrical changes in the cell. Within the cell, and this series of electrical changes occur in a fixed pattern. This is the ventricular action potential. When the ventricular cell gets activated and results in the series of electrical changes within the cell, this is the ventricular action potential. This ventricular action potential has 5 phases. For convenience, we'll start with phase 4, that is the resting phase, and then there is phase 0, depolarization phase. Then there is phase 1, phase 2 is the plateau phase, and phase 3 is the repolarization phase. You don't need to remember ion channel names right now. What happens is phase 4, this is the resting phase where the cell is at rest, and this is polarized state. And phase 0 is the depolarization phase. This is the sudden upward movement. The cell becomes positive very quickly. Immediately after depolarization is the phase 1. This is the phase 1. There is a small drop in voltage potential. This phase is short, and right now this is not clinically very important for us. Next comes the phase 2. This is the plateau phase. The voltage remains almost flat for some time. This is the phase which allows for proper ventricular contraction. What happens is calcium ions move into the cell and potassium ions go out of the cell. The calcium ions which move into the cell will go and bind to the contractile proteins and result in ventricular contraction. Next is the phase 3 or repolarization phase. Here the cell gradually becomes negative again. The calcium channel which was open, causing the calcium ions to move into the cell, closes, but the potassium ion channel continues to remain open, and potassium ion continues to move out of the cell. Hence the cell slowly goes back to its negative state, and finally when repolarization is complete, the cell goes into phase 4 or the resting state. So one thing you have to remember is ECG does not record one ventricular cell. It records the summated electrical activity of millions of ventricular cells. This is the most important line, and I stress again and again, it is not one ventricular action potential which is represented in the ECG. It is the summated ventricular action potential of millions of ventricular cells. So now let's connect ventricular action potential to the ECG waves. So how this ventricular action potential is represented in a ECG, which is PQRS and a T wave. How this is translated to this? So what you have to remember is phase 0 or the resting phase is the baseline in the ECG. This is the baseline in the ECG. This is the resting phase. And when we are talking now, we are talking about ventricular action potential. So P wave in the ECG is not discussed, hence P wave is not needed for us right now, because P represents atrial contraction. Now phase 0 or the depolarization phase is the QRS complex, and then we have the plateau phase or the phase 2, that is the ST segment. And after ST segment, the phase 3, what we have is the T wave. So from this we realize QRS in ECG is depolarization phase of action potential. ST segment of ECG is the plateau phase of the action potential, and T waves in the ECG is the repolarization phase in the action potential. So the key takeaway from the whole conversation so far is that ECG waves are not just shapes, they are the surface reflection of the cellular events which occur in the ventricle. In the future videos, we will see how changes in depolarization produce changes in QRS complex, how changes in the plateau phase or phase 2 will result in ST elevation or depression, and changes in repolarization result in T wave abnormalities. Thank you.